Welcome to Scala UA conference. It's great.
Здравствуйте. Я, собственно, умею говорить по-украински и только мало по-русски, но я буду говорить по-английски. Hello, I'll speak in English, so don't worry if you don't know Russian, and my Russian isn't good enough for giving the talk anyway. And Ukrainian, I don't know at all. So, my name is Karl Podowski, I'm from Germany, and I'm kind of running my own company and do some kind of IT stuff. And that's what we do here, all of us, so I think let's start. Doesn't like me. Okay. So, the question is, we see the next slide, and then you have to think what you see there, okay? So, here we go. What is that? Just the hint, this is not Kiev. Okay? But we'll see. It's Robinson City. Okay, just think of Robinson Crusoe. This guy has this huge island just for himself, yeah? And just this one guy here. And the good thing is, you don't have to worry about these rules, you don't get crashes. Okay, you can crash yourself, but forget that for the moment, yeah? And you can use these roads in any way you like, yeah? So just think of this vehicle, left side, a little bit oversized, doesn't matter, yeah? There's no other guy, so why not, yeah? And we know this, there's a programming language that some of us maybe heard of it, and there we do these things like synchronized. Yeah? So what we do there is basically reserve the whole world for us, and then we do something, and then somebody else gets the whole world. And we have this thing, so we have different ways to do that, but they all end up the same concept. Yeah, you know this one. That's also very smart, because then we have the big hardware, and we just use one core for actually doing our work, but we can make use of the other cores to keep the framework running. So that's kind of keeping us busy. But is the question if we really want to keep our hardware idle, or if we want to make use of the hardware to do our job? Yes? And I think the Scala guys usually like to do their job done and not the framework or idle process or something like that. But it's not so easy. Yeah, the idea is we want to process big data, and big data needs big computing power, yeah? And so we need the hardware power. And so we have to introduce rules, because if we just use this one Robinson on the island, then we don't have that much power. We want to use more guys. And not in the sense that one uses this road and then he calls, okay, I'm done now, next guy can go off. So we want to use it really simultaneously. And so this is the functional city now, and now we actually have rules, maybe right-hand traffic, and maybe you need brakes and things, whatever, yeah? And then we have to think, what is really dangerous? So I just give you the most dangerous things in my point of view that we address with functional programming. So sharing objects is very dangerous. Yeah, you have like this object, and different guys change something at the same time, and you don't know where, when, what changes, and change happens while you do something else, and all these things. And even single-threaded, this can be dangerous, but in multi-threading anyway. And it's only dangerous if they are mutable. So once they're immutable, this thing is 100% okay if they are really immutable, and not some hidden mutability that hits you. Okay? And the other thing that we have is like functions. We have like functions that we call, and we don't really know when and where they are called and how often, and they do something and they do it more often than we want. And this can also be dangerous, but only if they have side effects. And if we have pure functions, then it doesn't matter because we can call them more or less. They always return the same result. Yeah? So that's it. So I think that's just two things where we can introduce rules, and if we have a good rule set, then we are fine and can do a lot of things in parallel and don't really need to make it unparalleled by blocking too much. Yes? And the thing here that interests us most is this issue of immutability, because it's a very powerful thing, but also can hurt. I mean, when you start programming functional languages, then you say, oh, I have to restart from scratch because I don't know anything anymore. And of course we learn with the time, but the thing is it looks expensive. Yeah? The thing is, each mutation, we do mutations of course, but then we create a fresh copy. And we don't touch the original one. And because we do that, the one who uses the original doesn't even realize that we create a copy, and everything is fine. But copying is expensive, and if we would really copy all the time everything, then we would defeat performance so badly that probably functional programming language wouldn't really have any chance. But it's not really that bad because we have like things that are immutable, but they, when we copy, we don't really copy everything, but we try to share things. That's what the libraries do more or less for us. And the typical example, if you have the single linked list, it's very easy. And if you have more involved structures, it's more harder. But there's ways to do that, and libraries that do that. So we don't have to worry too much. And for most purposes, this works really well enough. So the thing is, we should work by the book. We should try to be working with pure functions. We saw on the previous talk, if you were in this room, we get these things where we have I/O and we have to deal with them. It's a little bit involved, but let's say the functionality that does the calculation work. Then we can say, okay, let's try to be work with pure functions. Let's try to work only with immutable structures. And it's like this, use a little bit of non-immutable, then we can destroy everything if it's shared. So it's really a good idea. And then we can see, okay, we have like, this is the sequence, it's like the random access list, and there's an immutable variant, and there is a way to replace one element in the middle by something else, by creating a copy that has this change, and we can work with it, okay? And it copies, of course, a little bit, but is kind of smart, but in the end, the old thing is unchanged. So it's safe to use this, and we just have something new that is what we work with. And now we think of something when we have big data, like the trivial operation that we like to do is sort them, yeah? And sorting is something, okay, you have this sort function that is part of your programming language or your library, and Scala has something like that as well. It has a sort function, and we can use that, and it's interesting how we do that. And you will see that the typical interesting sort algorithms mostly work on arrays, and you just assume you can read and write in the array as you like, yeah? Or a list that is behaving like an array, that doesn't matter. Yeah, but then there are very good algorithms for that, and you can use them, and you can really process like as much as fits in the memory. When it goes beyond that, then it gets interesting, but maybe we'll implicitly get answers for that as well. But that's that. And when we have real examples, then this thing that we saw just before becomes slow. Yeah, it's possible, but it's a little bit slow, and it really gets unusable for big data. If we just look up the Knuth, yeah, and say, okay, I use quicksort, and then I use the array, and when I write, I use this pattern that I just showed a few slides ago. and it's not really usable. So I just tried to measure it, and I did a file that was like a few megabytes. It was less than 2 seconds with a heap sort with mutable lists, and it was like 169 seconds when you did the big amount of data. But when I tried this naive approach with the immutable list, where I tried to mutate it by creating a copy, then it was possible to sort the small one, but not really attractive. And the big one, 1 gigabyte, was like beyond what you could do. Okay? So we have to think a bit more how we do this, because we need to be able to do our job. And in this case, most of the time, and I really recommend you go there, we just use the Scala library. And as I said, it already has a sort function. And this sort function respects our immutability structure. So it doesn't sort in place, but it spits out a sorted copy, which is, by the way, immutable again. So we are kind of in a fine world. We'll see how this works. It's kind of interesting, but anyway, this thing is really easy, and we are already in a good way. Performance is quite okay, but I can tell you it can be beaten. Yeah, and if we are okay with this, we should use it. But if we really have like data and we have already exhausted our reasonable possibilities, it's a possibility to tweak these things. And if you do something that is not sorting, but another algorithm that's not in the library, then you have to deal with this kind of issue anyway. So I measured this thing again, and the difference was 169. I did a very naive heap sort with mutable arrays, by the way. And I did a library call, and it was like the heap sort was a bit better, and the other one was a little bit worse, but could be the other way around. So it's kind of, if you do that, then you don't really gain anything that's worth the effort to maintain this thing and to test it and whatever. But already possible quite easily to be in the same range, and if you work harder, you can be better than that. So, as I said, if you are happy with what you find, please use it. Yeah, it's easier to maintain, and we are following all the rules because the Scala guys did it and they had the rules in mind. So we are fine in this big city to use it simultaneously. And our code is maintainable because we have just one line instead of 100 or so, yeah? And that said, we are in the right world. So sometimes, actually, we are not happy. I just assume for the case of this talk that we want to sort data faster than the library, but you can't consider that you need algorithms that are not in the standard library where you really write your own stuff, and then you have to bother anyway to find quick algorithms for that. So we can just do like tweak our sorting a bit and then become faster, yes? And we can use different algorithms, so there is this quick sort and merge sort and heap sort, and then more exotic ones, but we can play a little bit and tune the algorithm. There are variants that are better and worse, and so on. So there is still possibility to gain a bit. And we can make the implementations better. It's the question, when we are 169 seconds instead of 177, will we get really an area that is worth the effort or not? But yeah, we have to see whether yes or no, and if it doesn't help, then don't use it. Use the one-liner because it's easier to maintain. So, there is the thing when we deal with big data that is very interesting, and that seems to be not seen in the libraries a lot, and that is actually we know a lot about our data. And we can just call this sort function, and the sort function assumes no knowledge at all whatsoever about the data. And it works very well, so you don't need any knowledge, just this one method to compare. Yeah, what is larger, what is smaller. Of course, you need that, otherwise its sorting is undefined. But we can just work with that, and it's fine. But actually, when we have data, for example, we have text, and we know we sort data, and we know it's Ukrainian text, for example. Yeah, and we know the language statistics, and we can apply this knowledge. Or we can just assume, okay, it's some kind of human language, it's already good enough, and make use of that. So the thing is, if we have perfect knowledge of our data, we can do a job like sorting in a big O of n instead of big O n log n. And the trick is, why the libraries don't have that. You all know that you have like something like an equals function and a hash code, and this pair together allows us to do things like hash maps. And then when we want to do sorted structures, yeah, we usually just use this compare method. But what you can add, and that is interesting for this area, and of course it's work, and it's a lot of work when you want to do it really well, but it's not so hard when you want to do something that's kind of good. You want something like another second hash code. And this thing is compatible with a comparison function. That means if you compare two values, and value A is greater or equal than value B, then you want this, I call it metric, yeah? You want the metric also to be greater or equal, yeah? And the point is the metric, of course, is in a smaller space. It's maybe a long integer or something like that. I wouldn't go any larger than a long integer, or maybe 32-bit integers. It doesn't matter, it's an implementation detail. But this thing is kind of course, we need the possibility that two different objects give the same, but never we have that it's incompatible with the ordering. So it's kind of a very similar relationship as the hash code to the equals. And if this thing is evenly distributed, then this thing becomes O.n, and if it's kind of badly distributed, then it can even be worse. It's like when you write a bad hash code, then your hash tables, hash sets and hash maps perform very badly. And if you write a really, really good hash code, then your hash structures become big O, the access becomes constant time. Yeah? And this is the same story. And the point is, if we have human languages, then if you just assume they are random strings and you write the metric for that assumption, you're already better than the quicksort and whatever. Yeah? And the sorting in this case is just like when you do naive sorting. Just assume you have playing cards, okay? Or something, whatever, pieces of paper and there's text on it. And you want to sort that. And you just think you have like this floor, yeah? And how do you sort them? You put them on the floor and you know the position where they will land about, and then you put them in the right spot, and then finally you go through and collect them, and then you have it sorted. And that's basically what this algorithm works like. It's called flash sort, and it uses this mechanism. It's a little bit more work to write it, but yeah, in the end it beats quicksort and merge sort and heap sort, even if you don't do really good metric functions. But it's a pain, because everything that you want to sort with this thing, everything needs this metric function, and you need to go back and add it to everything. So it's not something where you say, okay, we do it by default, because the people who invented Java didn't have this in mind, and therefore this facility isn't part of the language, and since that we don't have it as part of Scala, because this kind of stuff is heavily inherited from Java. But it's possible, it's not too hard, it's possible to do that, but it's not there. Okay, this is one approach, and I could tell you it helps a lot. I mean, I asked Donald Knuth once, yeah, and he told me, yeah, it's not worth it. It's just moving from O to N, big O N log N to big O N in best case, but maybe that's already a factor of 10 or a factor of 20, and that's saving us, yeah? And there's another approach, and typical sort algorithms just do single-threaded work, and you can parallelize it. So what we just say, these are all things we are just moving with stuff that is not compatible with the world, something like this, yeah, it doesn't fit on the normal road. But here it's kind of okay because it has its own road only for this guy, yeah? So that's what we kind of came up with. We want to do something that's kind of incompatible with what we normally do. So the first thing is, do we really have to do that? Or can we just rethink our algorithms? You can just say, okay, what is our theory of algorithms? And it has all been made with mutable arrays in mind, basically. And then we can say, okay, can we just do another theory that just is based on immutable collections? And in some cases you will find that it's possible. In some cases it's incredible hard work, and then it's possible. And sometimes you have a possibility to go there. I just mentioned the algorithm merge sort would work more easily than others. And for example, bubble sort would be very ugly, but it's anyway not an option because it's not performing. But yeah, it's worth thinking about it, but of course we have limited resources, and sometimes this isn't even leading anywhere because the performance price for this extra requirement is kind of too high. So just see, do we get there where we want? And if yes, then we are on a good track. And the other thing is, if you just think of it, the rules, right-hand traffic, using brakes, or whatever you have, and how size of the vehicles, they apply on the public roads. But if you have a garden, in your garden you can do what you want. Yeah, just think of this. You have the public road, and there you have to follow all the rules. But in your garden you can use this big thing, yeah, and do things like that. You only have to be careful what gets out of the garden. There you have to be compatible with the rest of the world. And I'm just saying, when you know Java guys think they are fine. They do like a collection, which is mutable, and then they wrap it in this unmodifiable thing of the collection library and give that away. And then, of course, the one who gets it can't modify it, but the one who, from where it originates, can still modify it. And so we are not really good, only if we say, okay, we are very disciplined and we don't do that. But it's not really enough. So you have to really think what that means, that it's safe. But as I said, within the garden, you can do what you want as long as it stays there, and as long as you go outside only with what you are allowed to go. And if you look how Scala does this sort function, what it does, it basically makes it a mutable list or mutable array, then calls the Java library function to sort it, and then packs it back into a copy that is immutable. So they do exactly this. So I guess it's kind of okay. And it's the thing that internally we can do our own way. And it's important in the APA, we have to be correct and immutable, and as I said, really, not just pretend to be, but we really have to be correct, yeah? And we still keep all the rules by that. We are fine. We can combine this in any way that we want. We are doing stuff that's compatible. And we can use functional multi-threaded code around everything. It's possible. Yeah? And as I said, Scala's library works like that. So when we talk about parallelizing, so we just were using algorithms that mutate arrays in our garden, but now we want to do things in parallel. And there it's the idea that we can, just a suggestion where I made a very good experience with, we can split our data into sections. And then write our software that each thread only works in one section. And we program it that way. It's our own, within our garden, so we can say we program it like that and we know what we're doing. And then it's possible to do that. For example, if we sort, we split the data in 4 sections or in 256 or whatever, yeah, and sort each one of them. And then in the end we merge it together. There's this merge sort which is exactly doing that. Yeah? And by the way, just if you think of sorting something that is beyond our memory, it's also a possibility to do like this. We put each section in one server, sort it there, using all the knowledge that we have, for example, of course, yeah. And then in the end we merge the data together with some aggregation operation. So it's actually also answering this, we can do that. And this is the idea, yeah, we split our garden and we have these rules, we always stay within the section. We program it like that. Yeah? And we can use an array and then each thread has a range in the array and we really program it like that, it stays within that. And as I said, it's all in our garden. It's not in the space that everybody uses, but it's our internal structures that we use temporarily for our operation. And then in the end, we, of course, provide structures that are copies of this. This copying is a little bit ugly because it's also O.n, but in this case, it doesn't hurt us too much because compared to what we do before, it's not so bad. Okay, so that's the idea. It's important to follow all the rules and to keep things simple, but not simpler than they are. Yeah. So if we need to do things that are a little bit involved, and if we just keep by the rules and then program around the immutable structures and it doesn't help us, maybe that's simpler than we really have it, because it makes actually things more complicated. We are beyond the optimum. And what is very important is what these rules mean, what they are made for. And as we see them, if we understand them right, we can do very good stuff, but still get our job done. And we have to keep APIs clean, that is extremely important, yeah? And as I said, internal implementation, we have some freedom if we create a copy of what we get in and then create a copy of what we get out. Maybe there's shortcuts to that do the same in a more economical way, but I guess that's up to you to think out about that when you actually write code. I mean, if you know Ruby, they have a very interesting facility. They have a method called freeze, which is basically present in any object, especially collections have that. And by that they transform it to an irrevertible to an immutable collection, for example. And then you don't have to copy it. But that's details, I think you can look into these details when you work with it, but I would try to do it with the facilities that are there. Okay, so that's basically it. We are a little bit faster than anticipated, but I guess that's okay. We have some space for questions now. And yeah, so please, if you have questions, ask them.
What's your particular experience in big data performance improvement, I would say? So that's what we're talking about, sorry performance improvement or parallelizing that. What's your concrete experience in that?
Okay, so if we just talk about the sorting, I don't remember the exact figures, but I know that you could, for example, beat the libc function of the Linux by quite a factor if you do the two approaches that I suggested. And if you do other stuff, of course it's harder to compare, but I would just say from very bad to moderately, it's always factors that are so terrible that you don't want to hear them, but that's of course then. And yeah, I think it's always good to think about these things, and you can gain, but it's very hard to say any numbers at the moment.
Okay, thank you.
In the beginning, you talked a little bit about big data and that passing immutable things is safe.
Yeah.
But actually often, and it's kind of a nightmare in Spark, object is not serializable. When you pass something that refers to a large object, it tries to serialize even though it's a mutable object, but it fails to do this. So I wonder, have you tried spores or any techniques to basically isolate passing even immutable functions and objects?
No, I haven't, but you give a good point. The serialization is kind of a bad inheritance from Java. And the point is here actually what is, I think, a fundamental weakness of serialization, that you kind of get things unserializable, because serialization is something that you inherit by an interface, and then whatever you derive from that becomes serializable even though it might not be. For example, you create an object that is serializable, and then you derive something and put a DB connection in there. It's no longer serializable, but the language and the infrastructure thinks that. And for that reason, you get these weird situations where something that should be serializable isn't, or vice versa. And I don't really know, but I think it's a bad inheritance, and we of course need to work around, and I guess we have to go to different libraries. I'm currently using like XML libraries for that, and that's of course XML or JSON. That's of course not really, when you want really big data, very performant, but neither is Java serialization. So I think that's a very interesting issue to see what is the usable serialization mechanism that works and that is performant and that is maintainable, and where we don't have to work, I don't know how much, for each minor object.
Thank you.
Any more questions? You may ask in Russian, maybe I understand it, but I'll answer in English.
Actually, regarding collections and immutable stuff, actually I was really surprised when I looked into sources that Scala library is quite inefficient in terms of it creates a huge amount of intermediary collections.
Just to give a point, I don't know if it's very popular here, but I think in this area Scala can learn a lot from Clojure, because they really invested very, very heavily to do very, very clever collections. And it's open source, so I guess the Scala community can look into how they have done it. And yeah, I think there's a lot of space, and they did it very they did it very well in that area, and Scala has to improve a bit. It's also, I was looking into the implementations and I thought, oh, okay.
Actually, there was a library, I think it was Galaxy, that basically rewrote intermediate collection operations like while loops or filters into loops instead of avoid creating of intermediary collections. But by now I don't see, so there was also a Blitz, but by now I don't see any meta-programming library that now effectively tries to rewrite all this intermediate collection creation.
Yeah, it's also an interesting thing that, I mean, many library implementations do a lot of copying that you can avoid. I just mentioned this idea that they had in the Ruby world, which I haven't seen anywhere else. And if you just look at libc of Unix or Linux, it copies also too much. It should copy less. And it's kind of when you do something and then you do it with the copying, and you are on a good way, and it's already hard to write these libraries, and to write them in such a way that you copy less is extremely hard. And so I guess there's still a lot of space to do better libraries. And then of course it's interesting, you have like 10 different libraries, and then you should kind of try to get a good one to the Scala guys that they adopt that, because then it will be a success. And otherwise it's very hard if you are somewhere in GitHub with the alternative collection library. The natural thing is always to use the one that is facility of the language. I mean, you see that in Java, the Java collection library sucks, and a lot of people use Guava, and a lot of people use Apache Commons, but I would say 80% use this crappy thing that Java comes with anyway, because Guava is kind of a step more to use. Yeah.
But I think in Scala it is quite important that you try to reach a certain level before you write productive code, because otherwise it's quite hard to do good things and you create things that you regret later. So I think you have to invest some time to get a level, and then you can do very good stuff.